so differentiation. So for differentiation, first let's go through the formula. Okay, so as you can see, the first one, when y equal to x to the power of n, dy dx equal to nx to the power of n minus 1. So what happened here is the power n move in front, and then the power n minus with 1. Okay, so that is the first formula. And then we have the way to write the first derivative. We write dy dx, or we write f prime of x. So the way to write second derivative, that means you do differentiation for twice. So we write d2y dx2, or f double prime of x. Okay, so this is the first formula. Okay, let's say one quick example. Okay, so if you have y equal to 1 over x cubed, so basically to do differentiation, you have to change it to this form, x to the power of something. So we change it to x to the power of negative 3. Okay, then after that we can start doing dy dx, or differentiation. We shift the power minus 3 in front, minus 3, and then the power will become n minus 1. So imagine minus 3 minus 1 again, become minus 4. So this is your first derivative. So you can simplify your answer in this way. Because x takes negative power, you can bring it to the bottom. It takes x to the power of positive 4. Okay, that's how we simplify. And then if you want to do second derivative, d2y dx2, so of course it is better to refer to this, rather than this. This form is not that convenient to refer to, so refer to this will be easier, where based on this formula again, so the power negative 4 you have to bring in front, and since there is a number there, you have to multiply with it. Negative 3 multiply with negative 4, so we get positive 12. Then the x will take power of negative 4 minus 1, which is negative 5. So again, since x has negative power, we can bring it to the bottom to take x to the power of 5. So we get 12 over x to the power of 5. Okay, so now next one, increasing function. Increasing function is where dy dx is greater than 0. So that means they have positive gradient, and the graph look like this. Yeah, so the graph is like keep going up, like that. Yeah, so either the first one or the second one. Yeah, keep going up. That is increasing function. Decreasing functions, dy dx is less than 0. You know, dy dx is gradient. So gradient is less than 0, meaning that the graph is like going down or going down like this. Okay, so gradient is always positive for increasing function, and the gradient look like this. I said the gradient here positive, the gradient here positive, positive, positive. Whereas decreasing function, the gradient is negative. Let's say you see the gradient. So what am I drawing there is the gradient of tangent. So the gradient here is gradient of tangent. You can see it's like going down. That is decreasing function with gradient that take negative value. Okay, stationary point, dy dx equal to 0. So for example, this is stationary point, dy dx equal to 0. That is the gradient of tangent is equal to 0 here and here. Okay. So the place that I put the tangent is at the maximum point. So you can see it is horizontal. The tangent is horizontal, so the gradient is 0 when it's horizontal. So likewise, for a minimum point, the gradient of tangent is horizontal line, so the gradient of tangent is 0. Okay, so now we look at 8.1. 8.1 is chain rule. Okay, chain rule. So chain rule, we have dy dx equal to dy du times du dx. Okay, so how to use this chain rule? Let's say one example. Okay, so applying chain rule. Okay, let's say I put it here. Chain rule. So let's say I have y equal to ax plus b to the power of n. So if you have the differentiation of these, so you can use chain rule as one of the options. So example, if I have y equal to 2x plus 3 to the power of 4. So if you use chain rule, then you have to do it like this. Let u equal to 2x plus 3. So everything in the bracket, you let it as u. So when you do so, your questions become y equal to u to the power of 4. Okay, so based on chain rule, right, we have two equations here. The first one is u in terms of x. You have to do du dx. Y in terms of u, you have to do dy du. So you have to differentiate this equation and differentiate this equation, and then you multiply them, then you get dy dx. Okay, so differentiate du dx. So differentiation of 2x, you will get 2. Differentiation of 3, you will get 0. Okay, so if you can't remember this, I just write here. Differentiation of any constant, dy dx is 0. Differentiation of constant with x power 1, dy dx is constant. So just for your extra formula for your reference. So now let's come back to here. Differentiation of 2x, you get 2. Differentiation of 3, you get 0. Now this side, dy du. So the differentiation of this, u to the power of 4. So power 4 will move in front. 4u to the power of 3. Okay, so we have du dx, we have dy du. So now we apply the chain rule. Dy dx equal to dy du times du dx. Dy du is 4u cubed. Du dx is 2. 8u cubed. 8. The u is 2x plus 3. X plus 3 cubed. Okay, so that is how we apply the chain rule. So of course, if you are not applying chain rule, right, so there is another way, a formula method. So if you are using formula method, we have y equal to ax plus b to the power of n, dy dx equal to n, where the power n moves in front, multiply with the bracket, but now the bracket takes power n minus 1, the power decreased by 1 unit. Then after that, you have to differentiate everything here. Differentiate. Whatever you get a only, then you put it at the back. So you get a. Differentiation of ax, you get a. Differentiation of b, you get 0. So only a remains. So simplify it, and ax plus b to the power of n minus 1. So you may just remember the formula and apply it straight away if you don't want to use chain rule. Of course, our formula can be more general. It's not just for linear form in the bracket. Even other form like quadratic, cubic, or reciprocal form, we can do in the similar way. So meaning that if you have y equal to whatever form, in general I just call it fx to the power of n. So the differentiation is, you bring the n in front, then multiply with the fx again, and the power of fx is n minus 1 now, then you have to differentiate everything in the bracket, differentiate the fx, become f prime of x. So in general we have this, okay? We have this as the general term, general way to differentiate something with power n. Okay, so that is to replace the chain rule. Now we continue, we look at 8.2, nature of stationary point. Okay, so stationary point, we already know one information, where dy dx is equal to 0. Yeah, equal to 0. And then no matter it's maximum or minimum, dy dx is also equal to 0. So the problem is how we know which one is maximum, which one is minimum. So we have to find the second derivative. So you have to find d2y dx2. Find d2y dx2. Then after that, next point, substitute x value of stationary point into the second derivative, and if you get positive for your second derivative, that means it is a minimum point. So if you substitute the x value of the stationary point to the second derivative and you get negative answer, then it means it is maximum point. So for stationary point, the conclusion is like this. Okay, let's say I put it here. So you are given with y equal to fx. This is the curve. So first you have to do dy dx. You differentiate it. So this is called the gradient function. Once you get your gradient function, the next step is you let dy dx equal to 0. Then you find x. Okay, so this is the next step. And then after that, you substitute x found into y equal to fx to find y. And then the x and the y is the coordinate of the stationary point. Okay, so once you get x, y as the coordinate of the stationary point, then you do d2y dx2, differentiate for the second time. Then you substitute x coordinates of the stationary point into d2y dx2. And then if your d2y dx2 is more than 0, then it is a minimum point. But if your d2y dx2 is less than 0, then it is a maximum point. Okay, so that is the whole scenario or the whole process of finding maximum and minimum point. Okay, so we look at 8.3, connected rate of change. Okay, so you will see chain rule again. This is basically chain rule. You want to find the rate of change of y, then you have to do, they will give you rate of change of x, for example. Then you have to relate the derivative by using chain rule. dy dt equal to dy dx times dx dt. Okay, chain rule, this one. So of course, to understand the rate of change, we need many examples. So I have one short examples here. Okay, let's go through quickly these questions. So the equation of a curve is given by the formula y equal to that. Calculate the gradient of the curve at the point where x equal to 1. So to find the gradient of the curve, we have to find dy dx. dy dx. So of course, to do dy dx, you will realize that this is not ready for differentiation yet. So I had to bring up the denominator and then take -1. So now I'm going to use this formula. Okay, so using chain rule is not my favorite. I'm going to use this straight away, faster, this formula. Okay, so based on that formula, so the power -1 bring in front, I get -6, 5 minus 2x, -2, and then differentiate the bracket, I get -2. So at the end, I get 12, 5 minus 2x, -2, 12, 5 minus 2x squared. So I get my derivative. This is called gradient functions. I can substitute 1 inside to find the gradient of curve at that point. So x is equal to 1, dy dx is equal to 12 over 5 minus 2, 1 squared. So 12 over 3 squared. So at the end we get 4 over 3. Okay, that is part 1. Now we look at part 2. A point with coordinates x, y move along a curve in such a way that the rate of increase of y has a constant value of 0.02 units per second. So when you see rate of increase of y, that is dy dt. dy dt is given as 0.02. dy dt is 0.02. So the other thing that you have to pay attention is increase. Then you take positive. If they say decrease, you have to put negative here. So they give us dy dt equal to 0.02, and then find the rate of increase of x. So that means you have to find dx dt when x is equal to 1. Okay, so we use our chain rule in this way. We always put the question at the left. That will be easier for us. So they want us to find the dx dt, we put it on the left, and then the information dy dt I put on the right. Then I have to multiply with another derivative. And what derivative is that? You have to figure it out by using the idea of balancing the equation. So as you can see, we already have dt on both sides of the equation. So I still need dx on the right to balance it. And I need to cancel out the dy, which is not on the left. So I managed to use chain rule, and this is the thing. And I need to put dy dt 0.02 and multiply with dx dy. dx dy is the upside down of the dy dx that I found from the first part. This is dy dx 4 over 3. So dx dy will be 3 over 4. 3 over 4. So 3 over 4. So I multiply them, then I will get 0.015. Okay, so and I will just take another few more minutes to go through one more things, which is tangent and normal. So if you have a curve y equal to fx, you want to find tangent or normal. So first you have to look at it in this way. Let's say this is your curve. Yeah, this is your curve y equal to fx. Let's say at this point P, xy, you want to find the tangent. So it looks like this. This is the tangent. Tangent is a straight line, touches the graph at one point. So that is tangent. And normal is this one, perpendicular with the tangent. So this straight line is normal. Okay, so how to find tangent? So you can see it in this way. You use y equal to fx, then you do differentiation, dy dx equal to f prime of x. So after that, let's say the point P here, I call it x1, y1. So now you substitute x with x1. Then you get dy dx equal to f prime x1. So this is gradient of tangent. So this is gradient of tangent. Then after that, you want to find equation of tangent. So you just do y minus y1. The y1 is from point P equal to gradient x minus x1. So this is the straight line equation. You see tangent is a straight line. So where the gradient is the dy dx, which is the f prime x1. The x1, y1 here is from point P. You substitute everything inside, then you get equation of tangent. So this is tangent. Okay, now let's take a quick look on how to find normal. So normal, we need to do extra thing here. Once you get, maybe I should start from here. Once you get gradient of tangent, then you use gradient of tangent times gradient of normal equal to -1. Then you get gradient of normal. Then after that, you use y minus y1 equal to gradient of normal x minus x1 to get the equation of normal. So again, the x1, y1 is the point P. So you substitute point P into point P. As you can see, point P is the point where the normal passes through. So you substitute point P into x1, y1. The gradient of normal is what we found here, what we found from the perpendicular formula. So after that, you simplified it into the form of y equal to mx plus c. Then you get the gradient of, you get the equation of normal. So likewise, for the equation of tangent, you simplified it to y equal to mx plus c. Then you get the equation of tangent. So that is all about tangent and normal.